Think about everything you know to exist, from the intricate microscopic cells inside a green leaf, out to the planets, the stars, and the spiraling arms of our own galaxy. It feels like a complete picture of reality. This visualization shows the total makeup of our universe. That entire catalog of known things, every atom, tree, rock, and star we can actually observe, fits entirely into this tiny slice of less than 5. Let's look first at that 25%. Dark matter. You can think of this as the cosmic glue. It provides the gravitational pull that allows massive structures like galaxies to exist. This animated physics model shows a spinning galaxy. When astrophysicists calculated the gravity generated by just the visible stars and gas, the math failed. There simply wasn't enough inward pull to hold it together. Spinning at that speed, the galaxy would tear itself apart, flinging its stars out into deep space. To keep those stars tightly clustered in stable orbits, there has to be an overarching invisible mass wrapped around them, providing a much stronger gravitational anchor. We know there is a lot of it out there, but what exactly is it? We can rule a few things out. It isn't dark clouds of normal, everyday matter, because those would emit regular particles that our telescopes could easily detect. It isn't antimatter either. When antimatter reacts with normal matter, it produces highly distinct gamma rays, and we don't see those signatures. And it isn't a bunch of hidden black holes. Black holes are incredibly compact objects that violently disrupt their immediate surroundings, whereas dark matter appears to be smoothly and widely diffused throughout the entire universe. Here, we have a diagram illustrating gravitational lensing, which is the best observable evidence we have for this phenomenon. When light from a distant star travels toward Earth and passes near a high concentration of dark matter, the immense gravity of that invisible mass physically warps the light waves, bending their path. While the exact exotic particle making up dark matter remains elusive, its heavy presence is undeniable. It is the framework that allowed matter to clump together and form every complex physical structure in the cosmos, including our own planet. Gravity is only half the equation. The remaining 70% of the universe belongs to an even stranger phenomenon known as dark energy. If dark matter is the pull holding things together, dark energy is the opposing push tearing the universe apart. In 1929, Edwin Hubble examined the light emitted by distant galaxies, uncovering a pattern that pointed to a much larger cosmic motion. This graphic demonstrates what Hubble observed, a process called redshift. As light travels across massive distances to reach our telescopes, the wavelengths are physically stretching out toward the red end of the electromagnetic spectrum. Hubble deduced that this redshift happens because the empty space between the galaxies is physically expanding. The universe is actively stretching in all directions, carrying the galaxies further and further away from us. For decades, scientists assumed the gravitational pull of all the matter in the universe would eventually cause this expansion to slow down. However, recent observations show the expansion is actually accelerating. Space itself doesn't thin out or change its physical properties as it expands. Instead, entirely new empty space is constantly being generated, everywhere, all at once. Astrophysicists are exploring several theories to explain this intrinsic energy. Some suggest empty space is constantly boiling with temporary virtual particles spontaneously popping in and out of existence. Others propose a dynamic fluid that permeates the universe, exerting a negative pressure. Interestingly, this behaves very much like an idea Albert Einstein proposed back in 1917. He introduced a mathematical concept called the cosmological constant, a continuous repulsive force in the vacuum of space that directly counteracts the force of gravity. Empty space acts as a highly active engine, generating an inexplicable energy that gets stronger and more dominant with every passing second. Right now, we are sitting in the middle of a massive cosmic tug-of-war, and the intrinsic push of dark energy is currently overpowering the gravitational pull of dark matter. Because empty space contains its own repulsive energy, this process compounds. As the universe expands, it creates more empty space, which generates even more energy, driving the universe apart faster and faster. We have built sprawling cities, split the atom, and connected the globe instantly. But in the grand scheme of things, we are still apes with smartphones, sitting on a tiny, fragile island in space, trying to figure out how the sky works. Our theories about dark matter and dark energy are incomplete, and our equations don't yet give us the full picture. But a lack of absolute answers is not a scientific failure. Looking up into the night sky and realizing that 95% of the universe is a complete mystery isn't discouraging. It means astrophysics remains an active, thrilling frontier, with massive discoveries still waiting to be made.